So in question number 6, they're asking us again to go back to our answer for number 3 and to consider what a few more problems have in common. They want us to focus now on letters C, D, and E. So going back to page 2 then, C had an answer of 24, D had an answer of 1, and E had an answer of 1/4. None of those seem particularly helpful to me because those don't have anything in common, and more importantly, those don't appear to have anything to do with the actual expression. Like 24 doesn't have anything to do with 6, 1/2, or -2, at least not to my untrained eye. The 1 doesn't have anything to do with the 1/5 or the 1/5. I mean, like maybe this -1, but it doesn't seem like the exponent was supposed to be the answer because that didn't happen in letter C. And in letter E, again, I'm seeing something where it's not clear where I'm supposed to make a connection. Like 16 and 4, 1/4, like that's not really on the surface super obvious, and this -3 definitely doesn't seem to fit numerically. So I'm looking at these and perhaps a little bit stumped at first. What am I supposed to see about these things? And the only thing, if you stared at this question and thought, what in the world am I supposed to think that they have in common? The only thing that these problems actually had in common, and I'll just tell you in case you wouldn't have noticed this yourself, is that they all had negative exponents. That actually was the thing that drew all of these together. These were the only 3 questions in problem number 3 that had negative powers. All of the other questions had 0 exponents or positive exponents. These were the 3 questions that had negative exponents. So in terms of a commonality that you can write in number 6, letter A, they all have negative exponents. They were all referring to the idea that you had to go backwards in their tables. So assuming that I still have my table, and hopefully you do the same, from my work for letter C, which was one of the negative exponent problems, let's see if we can try to figure out like what that negative exponent might have had to do with anything. When I looked at letter C originally, I noticed that they gave me the 6, that was the initial value. They told me that the multiplier was 1/2, but that wasn't very helpful because they wanted me to go backwards to the negative second term. So I ended up having to multiply by 2, the reciprocal of the multiplier. Now, generally speaking, I had to multiply by 2 to go backwards. And it was that idea of reciprocating. I had to multiply not by 1/2, even though the question had a multiplier of 1/2. I wasn't actually multiplying in 1/2 or by 1/2 in this problem. I was actually doing 6 multiplying by 2, and because I had to do it twice, I had to go backwards the first time, multiply by 2, and then I had to go backwards the second time and multiply by 2. I was actually multiplying by 2 twice. And if you look at this expression that I just wrote, I said what I was doing, but I was writing it in math terms as I wrote it. I was taking that 6, my initial value, and to go backwards, I was multiplying by 2 and then multiplying by 2 again, which means I had a multiplier of 2 twice. Remember, an exponent tells you how many times you're multiplying something? If you look at that expression mathematically and follow the order of operations, exponent 2 squared would be 4. 4 times 6 is 24, and that is what I got. And that might not seem revolutionary to you. You might have said, well, of course, Herbert, of course that's 24. But notice the relationship between the expression that I just wrote and the original problem. That this original problem gave me the same answer as this rewritten expression. And notice what happened. The exponent became positive 2 because I was saying how many times I was going backwards. And to indicate that I was going backwards, I changed the multiplier. Instead of the forwards multiplier, which was 1/2, the backwards multiplier was the reciprocal, was multiplying by 2. And that actually brings to mind another really important rule of exponents. This is actually a rule of exponents that, again, you may have learned in a past class, maybe not, just depends, but it's actually a rule that has to do with negative exponents. That if you have, and I'll just call it an initial value, and some sort of multiplier, 1 over some sort of number, I'll call it, I don't know, some sort of number. We'll call it P. I'm just making up a letter there. to the power of a negative exponent. So negative exponent. So you'll notice I'm using kind of a hybrid here of words and letters, but it's mostly just so you can see the idea. That if you have this dividing type of problem, 1 over p means you're dividing by p. You're multiplying by 1 over p, but really technically you're just dividing by p. Then to go backwards, that's like saying, no. Instead of dividing by p, you're going to multiply by p. And the exponent just becomes how many times you need to go backwards, but you don't need to worry about the minus sign. You just need to worry about the fact that it's a directional thing. Minus sign or the negative sign just tells you to go backwards. So the number of times you go backwards is still the exponent. And that essentially means that the multiplier that you use can just be the reciprocal of this fraction. And if you want to rewrite the multiplier as a reciprocal, it essentially just makes the exponent positive. Because by reciprocating it, you're making it go backwards. Negative exponents just mean go backwards, but it's confusing. Like if I say, hey, take 6 and multiply it by 1/2 negative 2 times. What? How does that make sense? Multiply it negative 2? How do you multiply something negative 2 times? The exponent is supposed to tell you how many times to do something. I mean, your parents aren't going to tell you, hey, go clean your room negative 2 times this week. What does that even mean? Like, that's not a number of times. So to turn the exponent into something logical, to turn the exponent into something where you can say, oh, multiply twice. Oh, I got it. The negative was just saying, do the opposite twice. Instead of dividing by 2, multiplying by 2. Instead of multiplying by 1/2, multiplying by 2. That's all it's saying. So the general rule is that a negative exponent reciprocates its base. That's the general rule of negative exponents. A negative exponent reciprocates its base. That is a fancy word, and I'm going to write it, but I just want to make sure that you can see it. A negative exponent reciprocates, and I'll use that word, but I'll give you a synonym in a second. Reciprocates its base. Reciprocates is a fancy math person way of saying flips. A negative exponent flips its base. So when we did that previous question, and again, I'll just put it back on scratch paper here so that you can see it, just using the same piece of scratch paper over and over again, sorry. The original question was 6 times 1/2 to the negative 2. We said, whoa, how do you multiply negative 2 times? That doesn't make any sense. What's going on? We would rewrite this problem as the reciprocal of 1/2 becomes multiplied by 2, or 2 over 1 as it were, and the power is really positive 2. That's what that really means. A negative exponent reciprocates its base is really just a fancy way of saying, hey, you have something with a negative exponent, just flip the base over, 1/2 becomes 2 over 1, and make the exponent positive. It's kind of a 2-step thing. First step, flip the base. And the base is what I've been calling the multiplier. So if that verbiage is confusing, apologies there. So essentially flip the base or flip the multiplier and make the power positive. If you want a quick and dirty way of giving yourself some notes here, that's essentially the key rule that you should take away from this. That if you have a negative exponent, so this can be a general rule for all negative exponents or negative powers, then you can think of it as a 2-step process. For anything with a negative power, so notice this is important enough that I'm highlighting it, maybe even for those of us who like to take notes on the front page of our packet where you keep a little bit of a cumulative note sheet, this is how to deal with any sort of negative powers. Flip its base, the part that serves as the multiplier, and make the power positive. That's kind of a 2-step process. That way, even if you're confused about the sequence thing, even if you're not sure how the initial value sequence table, even if you're not sure how all that works, don't worry about it. This is like a takeaway message that you can screenshot, that you can pay attention to, and that you can use in future examples. Let me show you how in question number 7 and prove to you that even if you don't understand the theory behind where this came from, you'll be okay. Take a look at number 7, letter A. Just identify what's its base. In this case, the base looks like it's 4. You can call it a base, you can call it a multiplier. It's the same idea. But it looks like the base or the multiplier is 4. Since it has a negative power, I know these steps apply. So I'm going to flip the base. The 4 becomes 1/4, because currently it is 4 over 1. The reciprocal of that is 1 over 4. And that's going to make the power positive. Now you'll notice I did throw parentheses around it, mostly because when I wrote the square, I didn't want it to make it look like it just belonged to the top number. Technically, the square belongs to the whole thing. But that's what I mean by make the power positive. Notice how it was a -2. When I flipped the base, I made it a +2. So now I'm just going to think about this like mathematically. 1/4 squared, well, that's just 1/4 times 1/4. And 1/4 times 1/4 is simply 1/16. Since it says do it without a calculator, I'm not going to bother converting that to a decimal. In letter B, same idea. Letter C, same idea. Notice how they all have negative exponents? So in letter B, I have a negative exponent again. That means, oh, okay, I'm going to do these 2 steps. The base is currently 2, so I'm going to reciprocate or flip the base. 2 over 1 becomes 1 over 2. I'm going to make the power positive. -3 becomes +3. And 1/2 cubed, well, that's just a multiplication I can do. That's 1/2 times 1/2 times 1/2, 3 times. 1 times 1 times 1 on the top is 1. And 2 times 2 times 2 on the bottom is 8, 1/8. So again, anything with a negative power just means 2 steps. Flip the base, or the multiplier, and make the power positive. Once you do that, you should create for yourself a nice, easy multiplication problem that you can totally do with basic multiplication skills. Even if you don't think about it as a sequence, even if you lost my train of thought about how the sequence is related, don't worry. It's just a series of steps that boils down to these 2 things. This is the takeaway message. By the time you get to some of the more complicated ones, like letter D, hopefully you'll see 1/2 to the power of -3 has a negative power. So again, these 2 rules apply. But notice this time, the base is already a fraction, 1/2. So if the first step here is flip the base, the flip of 1/2 is 2 over 1, or just 2. And then if I make the power positive, that becomes +3. So 2 over 1 to the power of 3, that looks kind of complicated, so maybe just think of it as 2 to the power of 3. Well, that's 2 times 2 times 2. 2 times 2 times 2 is just 8. So again, sometimes you can make these problems a lot easier for yourself if you just follow these 2 steps. One more example just so you can kind of see it. That way you can give yourself a good idea of how this works going forwards. In letter K, this one has an extra number outside, that 4. Well, that's like the initial value. Remember, the initial value is not really affected by this negative power thing. The negative power rule really just applies to the base or the multiplier in the problem. So when I do letter K, I'm going to leave the 4 outside, and I'm going to do this negative power rule only with the multiplier and the power itself, because those are the only 2 things affected by the rule. If I flip the base, this is currently 2, so its reciprocal is 1/2. Then the power positive, that means power of 2. Now I have a problem that I really have to think about for a second, because this is a PEMDAS problem, an order of operations problem. I have to do the exponent before I can multiply by the 4. So this is really 4 times 1/2 squared is 1/2 times 1/2. So I'll do that part. 1/2 times 1/2 is 1/4. So now I have 4 times 1/4. You can think of that as 4 over 1. Times 1/4, if you like to multiply fractions with other fractions, make it consistent. 4 times 1 on the top is 4. 1 times 4 on the bottom is 4. 4 divided by 4 is 1. You might have also seen this as the 4's cancel, leaving you with 1. That's also fine. But either way, since it's asking you in this question to not use a calculator, try if you can to adapt this negative power rule and turn everything into a basic multiplication that you can do with existing multiplication skills. Because this is the last video on the playlist, I just want to make a couple of closing comments here. Namely, that really the whole point of this was to take rules of exponents that you may have just learned in a class, like an Algebra 1 class or a middle school class, that may have just been told to you as, well, here's the rule of exponents. And they might not have ever said why that rule of exponents exists. Why does a negative power mean flip and make the power positive? Why does a 0 power essentially become a 1? Why do those things work? The purpose of this lesson was to just show you in your understanding of sequences why those rules apply. It's not that the why is really the most important part. At the end of the day, the most important part is that you know the rules and can use the rules. But rules without meaning are easy to forget. Usually if I just said, hey, memorize a rule, we'd be fine for the first couple of days. But then fast forward a couple of months or to the next class in another year, we would say, oh, what was that rule again? Because if we don't understand why it worked or why it existed, it's just like a random piece of information. It's like a name for a person you only met once. If you don't have a reason to remember them, it's out of sight, out of mind. Once you forget them, it's gone forever. So hopefully this gives you a sense of why those rules of exponents work. Ultimately, you just need to remember the rules or write them down, because obviously you'll have access to your notes for the rest of the year. So write them in a place that you can remember them, but try to make the effort to understand the why behind them. Question number 5 is just going to ask you an application question with this idea in mind. It's just a sequence problem, so you're really just tying together what you know about sequences with what you now know about this new way of thinking about the rules of exponents, but this question just attempts to tie it together. The answer key for this question is available. If there's something that you need to ask about, you're certainly welcome to send me an email and ask about question number 5, but hopefully you'll find that between the answer key and what we've learned in the past videos in this playlist, you should be okay with question number 5 and the rest of question number 4 with your existing skills. Good luck.